Greetings, Year 9 mathematicians, to the fifth class or fifth topic on this chapter. Today we're going to be talking about surface area, but focusing only on prisms and pyramids. So let's get into it. Now, surface area means that we're actually finding the area around the outside of some solid shape. It'll be a three-dimensional shape. And sometimes you need to realize that you can't always see all of the sides when you're looking at the shape when it's drawn on a piece of paper. For example, here is a cube. Well, we know cubes have 6 sides, but we can only see the top, the right side, and the front side of this particular cube. But there are still 3 sides that we can't see. So we need to make sure that we factor that into it so we can see the front, the right, and the top, but we can't see the left or the bottom or the back. Now, when you're talking about three-dimensional objects or solids, we can actually break them up into flat surfaces. So for example, if we actually have a rectangular prism that's got 6 sides, or if we have a square-based pyramid that actually has 5 sides. We look at the first one. There are 6 rectangles. There's 4 around the outside, 1 on the top, 1 on the bottom. With our square-based pyramid, there are 4 triangles and a square base. So we need to make sure we know how many sides there are on the shape. You can see from my rectangular prism here, we can see the front, the top, and the right. Well, we can look at the front, the top, and the right, but we also need to recognize that there's a left and a back and a bottom, and that there are 6 sides. You could actually create a net. So you could actually unfold your shape and then look at the rectangles or the shapes that are created from doing that. Now here are some of the formulas that you're going to need to understand for this particular surface area unit. Rectangular prism, a bit like a shoebox. This is the fastest way you can find the surface area. You could actually break it up into 6 rectangles and find the area of all 6 sides and add them together, or you can use this formula, and we'll see an example where I actually do it both ways soon. A cube has 6 squares that are exactly the same length. Now whether I use L for length or S for side length or X, it doesn't matter. It's 6 times the side length squared, because the area of one of the squares is, in this case, L squared. When you see a square-based pyramid, you've got a square on the bottom and 4 triangles, and you just find the area of all of those 5 shapes and add them up. So, question 1 or example 1 says to find the surface area of a cube with a dimension of 3 centimeters. So, here's my little quick diagram. We've got a cube, 3 centimeters all the way around. Surface area of a cube, there are 6 squares that we know are on a cube, and each square is 3 centimeters by 3 centimeters, so 6 lots of 3 squared, which is 54 square centimeters. Do you have to write this part and this part? No, I don't mind. You can just go straight to 6 lots of 3 squared if you want, or it might be safe to write the formula, what you put into the calculator, and the answer. Let's go and have a look at example 2. Now, there's 2 methods. I would suggest not copying down, just watching method 1, because method 2 is by far the fastest method. But let's have a look at method 1. This is a method you use if you don't know the formula. Find the surface area of the following rectangular prism. Well, we look at it and we go, oh, there's a rectangle on the top. And the rectangle on the top is length times width, which is 15 by 12. So I put that into my calculator, and the top rectangle is 180. The front rectangle is 12 by 4. So the front rectangle is 48 square centimeters. The rectangle on the side on the left is 15 by 4. So I find out 15 by 4, which is 60. And then I actually have to take into account that there are 2 rectangles that are the same as each other, top and bottom, left and right, front and back. And I can do 2 lots of all of those parts added together, and that gives me the surface area of 576 square centimeters for this shape. Now, method 2, far quicker if you learn this formula. L, B, and H are just the length, the breadth, and the height, and it doesn't matter which one is which. You could have L is 4, B is 12, H is 15, or L is 15, B is 4, H is 12. Doesn't matter about the combination. Just call one of them L, one of them B, and one of them H. And in this case, I've said let L be 15, B be 12, and H be 4. And really it doesn't matter. You just effectively do 2 lots of 15 times 12 plus 12 times 4 plus 4 times 15. Doesn't really matter about the order as long as you multiply those together. Put it into the calculator. There is your answer. Much faster than method 1. Let's look at example 3. A square-based pyramid. Well, let's focus on the square on the bottom. The area of a square is just the side length squared. 14 times 14 is 196 millimeters squared in this case. Now with this particular pyramid, because the base is a square, and we're assuming the tip is in the middle of the square, the tip of the pyramid, we are going to say that each of the triangles on the side are exactly the same as each other. So if we can find the area of one triangle, we just times it by 4 because there are 4 triangles. So we know the area of a triangle is a half of the base times the perpendicular height, which in this case is 9. Half of 14 times 9 is 63. So the full surface area is going to be the area of the square plus the area of 4 triangles. So it's 196 plus 4 times 63, which is 448 millimeters squared if you put that into your calculator. As always, have fun as you work your way through the questions. Bye for now.